Hey everyone, and welcome back to Study with Pröf Düdü. Today, we're going to tackle a topic that sounds, a little weird. Surds. But trust me, they're the key to writing some numbers with absolute perfect accuracy. And by the end of this, you're going to be handling them like a total pro. So, if you're ready to get started, make sure you've hit that like and subscribe button. All right, let's jump right in.
So, let's kick things off with a little puzzle. Imagine you've got a square and its area is exactly 50 square centimeters. Now, we know the area of a square is just the side length multiplied by itself. So, what number times itself gets you to 50? It's not 7, because 7 squared is 49. And it's not 8, because 8 squared is 64. The exact answer is the square root of 50. But how do we actually use that number without just rounding it off and losing that precision? And that right there is exactly why we need surds.
Here's our game plan for today. First, we'll cover what surds actually are. Then we'll jump into the really important skills, simplifying them, adding and subtracting, and then multiplying. We'll also tackle a really crucial technique called rationalizing. And, of course, we'll wrap it all up with a quick recap and some practice problems so you can be sure you've got it down.
All right, section 1. So what in the world is a surd anyway?
Okay, so in simple terms, a surd is just a root, like a square root, that you can't simplify down into a nice, neat whole number or a simple fraction. It's a type of irrational number, which just means if you wrote it as a decimal, it would go on and on forever and ever without repeating. The real power of a surd is that it lets us write that number perfectly, with no rounding needed at all. Let's put this side by side so you can really see it. The square root of 9, that's just 3. Easy, it's a whole number. So root 9? Nope, not a surd. But then you look at the square root of 3. If you punch that into a calculator, you get this crazy long decimal, 1.732, and it just keeps going, forever, with no pattern. Since we can't write it as a neat number, we leave it as the square root of 3. That's a surd, and it's the most accurate way to write that value.
All right, time for our first big skill, simplifying surds. And the whole point of this, really, is to make that number under the root sign as tiny as we possibly can, without actually changing the value of the whole expression.
Don't worry, it's a simple 3-step recipe. Step 1, you need to find a factor of your number that's a perfect square. Like 4, 9, 16, 25. Those guys. Step 2, you split the surd into 2 separate roots being multiplied. And step 3, you just simplify the perfect square part. Let's see it in action.
Okay, let's do one together. Let's try simplifying the square root of 12. Okay, step 1. Let's think about the factors of 12. We've got 2 times 6, 1 and 12. But what about 4 and 3? 4, that's our perfect square. That's the one we want. So we rewrite the square root of 12 as the square root of 4 times 3.
Great. Now for step 2, we're going to use a really handy rule that lets us split this up into 2 separate roots. So we get the square root of 4 times the square root of 3.
And for the final easy step, we just clean it up. What's the square root of 4? It's 2, of course. We can't do anything more with the square root of 3, so that just stays put. And there we have it. Our final simplified answer is 2 root 3. See how we made the number under the root smaller? We went from 12 all the way down to 3. Perfect.
Okay, so remember that question from the very beginning about the square? The side length was the square root of 50? Can we simplify it? You bet we can. What's a perfect square factor of 50? Well, 25 is perfect. So root 50 is just root 25 times 2. Split it up. Root 25 times root 2. And that gives us 5 root 2 centimeters. See? Super useful.
Awesome job. Now that you're experts at simplifying, let's see how we can add and subtract these things. And here's a little secret. If you can do basic algebra, you can totally do this.
Think about algebra for a second. You know how 7x plus 2x is 9x, right? You just combine them because they're like terms. Well, surds work exactly the same way. We treat surds with the same number under the root as like surds. So 7 root 3 plus 2 root 3 just gives us 9 root 3. The key thing to remember, though, is you can only add or subtract them if the number under the root is exactly the same.
Okay, this is probably the most important rule for adding and subtracting, so listen up. You always have to simplify first. Look at this one. Root 24 plus root 96. Right now, they look totally different, right? You'd think you can't add them. But just watch what happens when we simplify.
Okay, let's break it down. Root 24, we can write that as root 4 times 6, which simplifies to 2 root 6. Now for root 96, a good factor is 16.
So that's root 16 times 6, which is 4 root 6. And would you look at that? All of a sudden, they are like surds. Now we can just add them. 2 root 6 plus 4 root 6 gives us our final answer, 6 root 6. See? It's like magic.
All right, moving on to multiplication. And you're going to love this because it's actually way easier than adding and subtracting. There's just one simple rule. Outsides with outsides, insides with insides. Okay, so take a look at this. 5 root 2 times 4 root 3. We just follow the rule. Multiply the numbers on the outside, 5 times 4 is 20. Then multiply the numbers on the inside, 2 times 3 is 6. Stick it all back together, and you get 20 root 6. That's it, simple as that.
So what happens if you get brackets? Don't panic. It's just like algebra again. Remember FOIL? First, outside, inside, last. You do exactly the same thing here. We do the firsts, the outsides, the insides, and the lasts. Then you look for any like terms to combine, but in this case all the roots are different, so we're already done. That whole thing is our final answer.
Okay, team, we've made it to the final big skill, rationalizing the denominator. Now, I know that sounds super complicated, but the idea behind it is actually pretty simple. It's just a rule in math. We don't like to leave a surd on the bottom of a fraction. This was just how we clean it up.
And to do this, we have a secret weapon. It's called the conjugate. When you have an expression with two parts, like 3 minus root 5, we call that a binomial surd. And its conjugate? Well, you just flip the sign in the middle. That's it. And here's the cool part. Whenever you multiply a surd by its conjugate, all the root parts magically disappear, leaving you with a nice normal number.
Let's look at a few examples so it really clicks. If you have 3 minus root 5, the conjugate is 3 plus root 5. If you have root a plus root b, the conjugate is root a minus root b. And for 2 plus 3 root 5, you guessed it, it's 2 minus 3 root 5. All you're doing is flipping that middle sign. Easy.
All right, let's use this in a real problem. We want to rationalize 1 over 3 minus root 5. So what do? We multiply the top and the bottom by the conjugate, which is 3 plus root 5. On the top, 1 times anything is just itself, so we get 3 plus root 5. Now on the bottom, this is where the magic happens. When you multiply it out, you get 9 minus 5, which is just 4. So our final cleaned up answer is 3 plus root 5, all divided by 4. And look, no more surd on the bottom. Job done.
You guys have done amazing. We've covered a ton of stuff today. So now it's time to put it all into practice and see what you've learned.
Okay, I've got 3 practice questions for you here. I really want you to pause the video in a second, actually try them out on paper and see how you do. The first one is adding, remember the big rule. The second is expanding brackets, and the third is rationalizing. All right, go ahead and hit pause now. Give it your best shot.
All right, you ready to check your answers? Let's see how you did. For number 1, after simplifying, you should have gotten 7 root 3. For number 2, when you expand and simplify everything, you end up with 5 minus 2 root 3. And for the last one, after rationalizing, you get 2 times the quantity root 5 plus 1. Don't worry if you didn't get them all right away. Practice is key.
And that's a wrap on our deep dive into surds. Seriously, great work today. The big thing to remember is that even though this stuff looks tricky at first, it's all about following a few simple rules. If this helped you out, it would mean the world if you'd like, share, and subscribe to Study with Pröf Düdü. Keep working hard, stay curious, and always remember, every single problem has a solution.